multiply them, and then subtract the exact same thing, that's still 0, isn't it? Now, why I did that, like how I came up with that, like to use that is not what this is about, okay? Someone else figured that out, and it took them a long time to figure out that's what to use, all right? But let's see what happens if you use that nice hidden 0. I'm now going to split this up into two limits. Limit h goes to 0. Now, when I split it, what I mean is I'm going to take, there's so many different ways I can do this. I'm going to take these two terms, put them together, and these two terms right here and put them together. So I'll have f of x plus h times g of x plus h minus f of x g of x plus h over h plus the other two together, f of x g of x plus h minus f of x g of x all over h. So do you buy that? I put this and this together. That's this. I put this and this together, and that's this. And I separated them out with a plus sign between them because they truly are, I mean, you could put them back together, right, and get back up to the line before. So is that all right? Now, on the yellow one, bottom left, what do those both the numerator, both terms in numerator, what do those both have in common? They both have a g of x plus h, right? So I'm going to factor out a g of x plus h, and what would I be left with? If I pull a g of x plus h out of the top, what's still there? F of x plus h minus f of x all over h. Now, I slid that g of x plus h out in front of everything, right? But it would just distribute back through here, and it would give me this line right here, wouldn't it? What on the second set of parentheses, or the second fraction, the blue one on the right, what do those both have in common? F of x. And what's left? G of x plus h minus g of x all over h. Now, this is the nice part. Let's let h go to 0, everyone. This equals, okay, what does g of x plus h go to if I let h go to 0? G of x, okay? Times, what is this? Yeah, go back, look in your notes, look at let me see. Look at 2.2.1. 2.2.1. About midway down in that, it tells you, it says, remember that a is in the formula, blah, blah, blah. Let's change it to x to get f prime of x equals limit h goes to 0 of f of x plus h minus f of x over h, isn't it? Isn't that what it says? So what is that part? That whole thing right there turns into what? F prime of x, doesn't it? That's what that is. That's f prime. That's the definition of the derivative of f. Isn't it? Plus, okay, now what does f of x turn into if you let h go to 0? Just f of x. But what is this whole thing? That's the derivative of g, isn't it? And that, my friends, is the product rule. It says that if you're trying to take the derivative of two things that are being multiplied, you don't just take the derivative of each one. You have to do g without the derivative times the derivative of f plus f without the derivative times the derivative of g. Okay, so that's the proof. I'm done. We usually just put a black box at the end to show it's done. Okay, therefore, here we go. This is the big result of product rule. Therefore, if I want to take the derivative of two functions, f and g, it's going to be equal to the derivative of f times g plus the derivative of g times f. Now, I changed the order there. Do y'all see that? Like in this red I had up here, it was g times the derivative of f. Since it's multiplication, I just flipped them over. And then over on this one, I had f and derivative g, I just flipped them over. That's the way that I've always taught it. That's the way that I don't even know if I learned it that way, but that's the way I teach it. In the book, it might appear in a different order because addition doesn't matter either. You can flip the addition around, and you could put this g prime f before. But there's a reason why I teach it that way. You'll see in a second. Questions? Another way to say this is if f is our first function and g is our second function, then it's the derivative of the first one times the second plus the derivative of the second one times the first, isn't it? You want to get comfortable saying what the product rule is, like in your head, because you have to memorize that formula, or you should have it memorized. All right, let's go to back to this example where we had y equals x times sine x. We already knew that that was a product, right? So since it's a product, I'm going to separate the two. I'm just going to draw a red line down the middle. There's my product right in between those. I'm going to identify what f is and what g is. F is the function x. G is the function sine x. So my derivative should be f prime times g plus g prime times f. What is the derivative of f? 1 times sine of x. That's just g by itself. Plus, what's the derivative of sine of x? Cosine x times f. What was f? X. Careful, that was the derivative of f. Does everyone see where all these things correspond to each other here? And we're pretty much there. I can just write sine x plus x cosine x. Why do you think I put the x out in front of the cosine on that second one here? Because it's not inside, right? Those two x's don't multiply and become x squared. Because that x in the cosine is trapped. So that x next to it has to be multiplied in front. And that is the derivative. What do you think? All right, let's try another one. Y equals x to the fifth plus x to the fourth plus x plus pi times 3 square root of x plus x squared minus x to the ninth plus 1. Now you could, if you wanted to, multiply this all out, couldn't you? Like you could expand this out. And if you did so, you would have, let's see how many terms. 1, 2, 3, 4, 1, 2, 3, 4. You would have 16 terms. You could try and collect like terms. And then you could do power rule on each one. Because aren't all of these powers of x? Aren't they? But a better way is to realize you have product rule right there. And that this whole thing right here is an f, and this whole thing is a g, isn't it? And so we know that the derivative is f prime g plus g prime f. So what is f prime? 5x to the fourth plus 4x cubed plus 1. And what's the derivative of pi? 0, because pi is a constant, right? So that's just f prime, isn't it? I have to multiply that times what? G, which is 3 root x plus x squared. So I'm not taking a derivative of g, right? I could. That's fine. It's not wrong to do it that way. Am I done? Now I have what? Plus g prime. 3 over 2 root x. How did I get that? Yep. Remember, I told y'all last class, everyone here should be comfortable. The derivative of the square root of x is 1 over 2 root x. Remember that? And then I have a 3 in front of it. So that 3 is on top of the 2 root x. Is that all right? Then what? Plus 2x minus 9x to the 8th. And then derivative 1 is 0. So I close that out. That's g prime. And then times f. I'm going to run out of room, so I'll put it below it. So f is just x to the 5th plus x to the 4th plus x plus pi. Now we're supposed to multiply that all out now. I'm not going to. That's the derivative, though, right? Isn't it? Which is what we're just trying to focus on that right now. Questions? Okay, let's try another one. Here's one that gets people sometimes. Y equals sine. Let's do sine cubed x. Now, this section is about product rule, right? So we need to first see this as a product of two things, right? So how can I look at this as a product of two things? How about sine x times sine squared x? That's a product, isn't it? And then I could look at the first one as being f and the second one as being g. Do y'all agree with that? We're going to run into a problem here. Y prime then should be f prime g plus g prime f. Do we know what f prime is? What's derivative of f? What's derivative of sine? Cosine x, right? So we'll be okay with that first part. But what about g prime? Do you know what the derivative of sine squared is? Well, that's a product also, isn't it? Isn't sine squared a product? So I actually need to do some scratch work on the side here. I need to come over here where I had g was equal to sine squared x, right? I need to look at g as being sine x times sine x. Notice that I have a product here and figure out its derivative. And then I'll plug that answer back in over here. Now, I can't use f and g. Why? Over here on the right side for my two functions. Because I'm already using g, right? So I can use anything I want. Yeah, why don't I use h and k? Then what is the derivative of g according to the product rule? H prime k plus k prime h. Do y'all see how that works? We just have a generic formula for product rule, using anything you want as far as letters. So g prime would then be the derivative of h, which is cosine x times k sine x plus the derivative of k, which is